So now we're getting into stuff that's more recent. So hopefully these types of problems are not too challenging. In 64, we have two secants. So the formula that goes along with that is taking the outside segment and then doing the inside segment plus the outside segment. All right, so it's outside times inside plus outside. And that's 2x times x plus 2x. So on the left-hand side, we get 3 times 8. And on the right-hand side, we get 2x times 3x. So 3 times 8 is 24. 2x times 3x is 6x squared. We can divide by 6, so we get 4 equals x squared. And then we have to take the square root, so 2 equals x. For 65, anytime a quadrilateral is inscribed in a circle, which means it's drawn inside the circle, our opposite angles are supplementary. So opposite x is 70. So 180 minus 70 is 110. Opposite y is 80, and 180 minus 80 is 100. And then for z, we have this arc here that's 120. And we also have the fact that angle x intercepts z and 120. So 2 times 110 is 220. So that's that entire arc. So for z, oops, 220 minus 120 tells us that z equals 100. For 66, we have a tangent and a secant. So the tangent part is just x, so we say x squared equals, and just like our other secants, it's outside times inside plus outside. So we have x squared equals 4 times 7. So x squared equals 28. And when we take the square root of 28, again, it's just 4 times 7, so we're able to simplify that to 2 square root of 7. The next problem is up here at 67. So we have a triangle with 2 congruent sides here, which means we can take 180 minus 50 and we get 130. And when we divide 130 into 2, then z equals 65. For y is intercepted by angle z here. So we can take 65 and we can times it by 2, and we get y, which is 130. Now x, if I erase my other angle, x intercepts this part of the circle, right? So we know y over here is 130. We know this one over here is going to be 130 because it's opposite the other angle there that was 65. And altogether that's 260. So if we take 360 minus 260, we get 100. And then the intercepted arc that our x is sitting at, we divide by 2, so x equals 50. For 68, I would say we could quite easily start with y here, right? Because 55 intercepts our y arc. So we can double 55, and y equals 110. For x, it's intercepting the 140 arc, so we can take 140 divided by 2, and we get 70. And if y is 110, and we have 140, that's 250, so we can take 360 minus 250, and we get 110 for z. Now for 69, our interception is outside of the circle, right there, okay? So we take 360 minus our x that we have sitting there on our arc. So over here is 360 minus x. So what we're going to do is we're going to take 58, set it equal to 1/2 360 minus x minus another x. Okay, so now we can go ahead and we can combine our 360 minus x, and we can also multiply by 2 so that way we can get rid of that half. Okay, so if we take care of all of that, we get, my pen's not working right now. (116) equals 360 minus 2x. Okay, and then we can go ahead and we can subtract our 360. So if we subtract 360 from the 116, I get a negative 244. But that equals a negative 2x. So we can take the negative 2 and do negative 244 divided by negative 2, and we get a positive 122 for x. For 70, same kind of thing, right? We're intercepting outside of our circle right here. This time, though, we have our 2 arc measurements. So 30 equals 1/2 x minus 70. So we get 60 equals x minus 70. And when you add 70, you get 130 equals x. (71), the interception is in the center. So, or not in the center, but inside our circle, I should say. So we can do 75 equals 1/2 100 plus x. And when you multiply by 2, we get 150 equals 100 plus x. And then we can subtract 100, so we get 50 equals x. For 72, x is intercepting that 50-degree arc, which means that when we divide by 2, x equals 25. And now we're also intercepting a semicircle, which means that entire measure on the right-hand side should be 180, and we have a 50-degree measure already taken, so that gives us 130. And since y intercepts the 130, we can take 130 divided by 2, and we get 65. For number 73, you have 3 congruent chords, which means we have 3 congruent arcs right along with it. So we already know that x equals y, and we're just going to figure out what they both equal. So we've already used 120 degrees, which means what we're left with is 240 for the other 3 sections. Now they all have to be congruent, so 240 divided by those other 3 sections leaves us with 80. For 74, we have a couple radius problems that we're going to do. All right? We have to draw in the radii when it comes to this. Okay? And then we're going to do Pythagorean theorem a few times over. So in the first part, we're told AB is 18. We're told OM is 12. We're told ON is 10. And then we want to find CD. So I'm going to draw a radius here from O to B. MB is going to be 9 because the radius is going to bisect that chord. OM is 12. And then we can go ahead and we can do Pythagorean theorem to figure out what the hypotenuse is going to be. And then that'll give us our radius measure. So if we take a look at that, we can do 12 squared plus 9 squared equals, let's say, r squared, since we're talking about the radius. So we get 144 plus 81 equals r squared. So 225 equals r squared. And when you take the square root of r squared, then your radius is 15. So looking at our circle here, this guy is 15, the radius that we just drew, which means that from O to C is also 15. And we know ON is 10. Now I'm going to kind of shorthand things here. If I take 15 and I square it, I still get that 225. So I'm going to do 225 minus 10 squared, so minus 100. So we get 125 equals, let's say, b squared. And when we take the square root of that, that simplifies to 5 square root 5. Now, that is only half of our CD that we need to find. So this is 5 square root 5. So if NC is 5 square root 5, DN should be the same. And when we add them together, we get 10 square root 5.